Lesson 45, Using Wide Char Array Strings. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. A wide char is similar to a char, except that they take up twice the space and can take on much larger values as a result. Chars can take on 256 values, which correspond to entries in the ASCII table. Wide chars can take on 65,536 values, which correspond to Unicode values. ASCII was an early American standard that was based on English. Unicode is a more recent international standard which allows for the encoding of characters for virtually all languages and commonly used symbols. In our first program, we demonstrate some differences between char array strings and wide char array strings. First, we declare a char array string and output it to the console window. Then we show how to do the same thing with a wide char array string. If we execute the program, we see zoax.net outputted twice. Both of the arrays shown here contain the same text and a null terminator to signal the end of the string. However, the wide character array uses twice as much memory to encode each character. There are a few differences between the code for chars and wide chars. First, the type declarations are char and wchar_t. Next, the string literal for the wide string is prepended with an L. This tells the compiler that the string is a wide char string instead of a char string. Finally, for output, we use wcout instead of cout to output wide chars. In general, char array strings and wide char array strings function very similarly. For the rest of our examples, we go over the same operations that we covered for char array strings and explain the minor differences. In this program, we ask what is your name, take in a string input, and output it back. The commands function exactly the same as the related char commands, but we use wchar_t for the type and prepend cout and cin with a w. Executing the program and typing in zoax.net, we see our name written back out with the final message. As we have done for char array strings, we can limit the number of characters taken as input to prevent overflow. In this program, we have replaced the insertion with a call to get line with a specified maximum of 10 characters taken in. Executing the program and typing in zoax.net lesson 45, we see that the output is truncated to 10 characters and the text lesson 45 is left out of the string. Most of the functions for working with wide character array strings are in the file cwchar, which we have included here. This simple program demonstrates how to get the length of a wide character array string. To do this, we just make a call to wcslen, which is short for wide character string length. Executing the program yields the expected result. This next program demonstrates how to copy a wide character array string by using the function wcscopy from the file cwchar. Executing the program, we see that the original string was copied properly. Here we have a program that demonstrates how to concatenate strings using the wcscat function from cwchar. We begin with the string zoax.net and concatenate a space and then lesson 45 to it. Note that it is important that our original array was 20 bytes long. If it wasn't long enough to hold the entire concatenation, then we would get a buffer overrun and the program would crash. Executing the program, we see our concatenation outputted. In order to be able to sort and search wide strings, we need to be able to compare them. The function that we use for comparison is wcscmp, which is also in cwchar. This function returns an integer less than 0 if the first string comes before the second alphabetically, 0 if they are equal, and some number greater than 0 if the first string is larger. Executing the program, we see the three values for our comparisons in this program. Our final program demonstrates how to tokenize a wide char array string into substrings. We begin with the string full of delimiters. We create a string delimiter list. In this case, we have only a comma. But we could use other things like spaces, dashes, etc., or we could use several delimiters at once. Our code begins by initializing the tokenizer with a call to wcstalk, which returns a pointer to the beginning of the string w and sets the first delimiter to 0. Below this, we have a while loop that outputs the current substring and gets the next one by repeating our function call with a null argument. Each successive call returns a substring pointer to the next substring and puts a null in place of the next delimiter. When there are no more substrings, the function returns a null pointer, and the while loop terminates. Executing the program, we see each of the substrings outputted. This concludes the lesson.